Hello there and welcome to Science with Coffee. In this lesson we're going to be going over the atomic theory lesson, however this is going to be the summary or review of it. So I will take out most of the extra details that you might not need or be tested on and just go to the straight key points. And I will also try to do this as quickly as possible, so if you want to see the full version you can check out that video as well. I'll link it down below. But if you just want the summary, this is the video for you. So we're going to kick off with the Greeks Leucippus and Democritus. They came up with atomos, which is the ancient Greek word for uncuttable. So just really quickly, they theorized that if you take something and keep cutting it and break it down to something that cannot be cut anymore. So there's something that is like the smallest unit of matter, basically. Then about 2,000 years later, you got Dalton. He came up with the billiards ball model of the atom, which is basically that it was indestructible as well as indivisible. And he came up and thought it looked like a sphere. Then along came Thomson roughly 100 years later, and he came up with the plum pudding model of the atom. So he looked at electric and magnetic fields to determine that there's positive and negatives inside the atom. Later, these were named as protons and electrons, so the first kind of finding of subatomic particles. Then along came Rutherford and his team. He did this experiment, which is the gold foil experiment, and there's three things that he saw when he shot alpha particles at gold with a then detector around the outside of it to see where these alpha particles ended up. So alpha particles are very small, very fast moving, and they are also very, very positive. So as these alpha particles hit gold foil, most of them went through. Some of them deflected to the side, and then some also deflected back towards the scientists. Now, the three things of these different directions allowed Rutherford to theorize a new concept of the atom, because obviously Thomson's model was incorrect. What he found out was most of the atom has to be empty space. So he came up with this planetary model of the atom. So most of it is empty space except for the center, which is the nucleus, and that is where you had something that is very, very positive and also something that is very, very dense. How he came up with these three things is most of the alpha particles went through the gold foil, which means most of the space was empty. They didn't hit anything and they went straight through. Some got deflected. This means that the alpha particles that are very positive came near the nucleus, and very positive alpha particles beside a very positive nucleus, it will repel and get deflected away. So he learned from the slight deflections that the nucleus must also be very, very positive. Then, when the particles bounced backwards, he then knew when the alpha particles struck the nucleus of the gold atoms, they were deflected backwards. So this meant that whatever those alpha particles were hitting were also very, very, very dense. So he got empty space, very dense, and very positive. Now, Rutherford's issue with this creation of this model that people were having was that the electrons here, that's E minus for an electron, that are spinning around, and again you will see this model floating around in the transitions of the Big Bang Theory if you watch that TV show. These electrons should come crashing into the nucleus, because the nucleus, what Rutherford found out, was very positive, electrons are negative, and they should be attracted to each other. So what Bohr then did is he looked at how the electrons were behaving with atoms, specifically hydrogen. So Rutherford mostly found out information about the nucleus. Bohr was looking at electrons. So he used some understanding of quantum mechanics to find out that when you excite electrons and they will move up different energy levels or different shells or orbits. And when they move up, they gain energy to move up. Then, if you stop energizing them, they can move back down. Now, what he saw by looking at emission spectrum and absorption spectrums is that when the electrons move up and move back down, they always move in the same spot. So there's discrete or specific areas that electrons can be found. This was a huge leap forward. Some could say a quantum leap, because here all the electrons are spinning around all willy-nilly in the planetary model, whereas Bohr found out a little bit more about the electrons and also found out a reason why they don't come spiraling into the nucleus. Now, also, we have Chadwick. Chadwick, he used cathode ray tubes and some other stuff that's quite complicated, and he found out about neutrons. So with Leucippus and Democritus to Dalton to Chadwick, we now found out roughly what the atoms look like up until roughly about 1935 or so. This is roughly what we knew. Now, I will draw a Bohr-Rutherford diagram in a moment, which is kind of the accumulation of all of this knowledge, and that is the fundamental diagram or model that we'll be using to explain the atom. Now, it's not perfect, and it's definitely not as complicated as what we know now. However, it works very, very well for understanding the fundamentals or foundational knowledge of chemistry. So here's what the final model or diagram of the Bohr-Rutherford diagram is, with all of the accumulated knowledge till about 1935. You have your protons in the center along with your neutrons, and then your electrons are spinning around in shells or orbits or energy levels, depending on how you look at your atoms, around the nucleus, which contains, again, the protons and neutrons. This is the Bohr-Rutherford diagram of carbon, and in the next videos I will go over the information about protons, neutrons, and electrons in order to understand what this is and how it all works. And then I will give you the information that you need to draw these, and I will go over the conventions of drawing them as well as practicing that information as well. So I'll end this video here. I hope that helped. If you have any questions, shoot them down below. And the tip was sleep is very important. Here's a photo of the stars as seen from the desert in Namibia, and the band from lesson 2 is Alt J. Definitely check them out. And with that, if you enjoyed this or this helped you, please like the video, hit the bell, subscribe, and most importantly, always beat the ball.